Hi, everybody. We're going to talk scientific notation. If you don't feel like you need to listen to this video because you get scientific notation, more power to you. You can get all the information that you need about scientific notation in your book if you'd rather read about it. I'm just going to talk through it for those of you that like to listen, who are more auditory learners rather than visual learners. Okay, so what is scientific notation? Well, lots of you have done this in math class. You just didn't know it was called scientific notation. So it's a way that we can express a number, usually a really big number or a really small number, but not always, by moving the decimal so that it makes the number between 1 and 10. And then we multiply it by the number 10 and raise it to a power, which is called the exponent. If that didn't make any sense, don't worry, it will in just a minute. The number of places that the decimal had to be moved, either to the right or to the left, that is what equals the exponent. So here's the general formula for scientific notation. Scientific notation not only allows us to write extremely large or extremely small numbers efficiently, but it also allows us to indicate which zeros are placeholders. Remember, we were struggling with that with with significant figures, which in a really, really long number, let me give you an example. Here's a really, really long number. In a really, really long number, which of those zeros are significant? Now, there is a naming convention that says that you can put a line over the top of one of those zeros, but when there is no line, it's a little confusing about which of those zeros are actually significant. So let's figure out how we can do that more efficiently. So we're going to practice this first. It says, write the width of the universe in scientific notation. Whew, that is a wicked big number. I don't even know what that number is, but it says, where is the decimal point now? Well, technically the decimal point is all the way at the end, so it's after the last zero. So where would you put the decimal point in order to make this number between 1 and 10? Well, you're going to scoot it all the way over and drop that little decimal point between the 2 and the 1. So then the question becomes, how many zeros, how many decimal places did you scoot that decimal point over? So you scooted it over in order to go from the end all the way between the 2 and the 1. You moved it 23 places. The number 23 then becomes our exponent. When the original number, which was 210 gazillion, I didn't pay attention, is more than 1, then we say the exponent is positive. So the answer when we write it in scientific notation is just 2.1 times 10 to the 23rd. But here's the issue I have. What if one of those zeros or more than one of those zeros was actually significant? The way we wrote it here, we implied that this entire number was rounded off and the only two significant figures were the 2 and the 1. That's it. So what if some of those zeros are actually significant? Remember, there's this naming convention where you can make a line over the zero. Do you see the line over one of the zeros here? That's not a real efficient way of doing it. So scientific notation provides a better way of doing it. In this example that I have, the first 3 zeros were significant. It implies that our measuring tool was actually that precise, and it was 21000 on our measuring tool, and then the rest of it is just estimated. The rest of it is just rounded off. So how does that change the scientific notation? It's not complicated at all. You just get to add those 3 zeros after the 1. And now going back to what you know about sig figs, look at the number 2.1000. How many sig figs does that number have? It has 5. When you have zeros after a non-zero, after a decimal, they're all significant. The more you practice this, you guys, the better you'll get at it. So if it makes your head spin at first, you'll get better at it. All right, so now we can see exactly how precise that measurement was now that we write it in scientific notation. Okay, let's try a few practice problems. So let's express this very, very, very tiny number in scientific notation. This time we have to move the decimal point in the opposite direction. So what is that going to mean for the exponent? How's that going to affect the exponent? All right, so it says, where would the decimal go in order to make the number between 1 and 10? Well, it has to go between the 9 and the 0, so we'd make it 9.02. How many spaces did we move it? We moved it 8. So now if we're going to write this in scientific notation, it's 9.02 times 10 to the negative 8 because we went the opposite direction. If it's a wee number, you make it a negative sign. If it's a humongous number, you make it a positive sign for the exponent. All right, so here we have one practice. Look at it. Do it in your head. Write this number in scientific notation. What would that be? Well, okay, you got to figure out how many decimals you got to move it over. You want the decimal to be between the 2 and the 8. So 2.87509 times 10 to the, and you would have moved it 1, 2, 3, 4 spaces. So number 3 would be the right answer on that one. All right, let's try another one. Can you express 1.8 times 10 to the negative 4 in decimal notation? Now, the negative 4 means that it's a wee number. So you would take the decimal that's 1.8, you get that 0.8, and you'd move it 4 to the, let's see, it's hard to say that when I'm pointing at you guys. You move it so that it makes it a smaller number. So you move it 1 in front of the 1, now in front of a 0, a 0, a 0. You move it 4 spaces so that you can indicate it that way. Vice versa, since this exponent is positive, 4.58 times 10 to the 6, a positive number, you're going to move the decimal in the opposite direction. And so we're going to have a really big number. On the graphing calculator, scientific notation is done with the E button, which stands for exponent. And that's going to screw some people up. And so we definitely need to talk about that. So you could do 4.5 times 10 to the 6 as 4.58, E6. And that will give you the right answer. So that's one way to do it. Now, I want you, it would be handy if you had a calculator handy to actually try doing this particular equation on your calculator. So you do 7.2 times 10 to the negative 9 over 1.2 times 10 to the positive 2. In your textbook, it teaches you how to figure out if you've got a negative 9 on the top and you're dividing by a positive 2 on the bottom, how those exponents will work out. But you get to use calculators, so the calculator is going to do that for you. I think it's a shame if you don't know how to do it on your own, but you can use your calculator as a crutch. However, there's a huge issue. Students come up to me with this all the time, so I need you to figure this out and to not come up to me and ask me this question because you need to know this. Your calculator might tell you something like 6e to the negative 11. It'll usually have a little decimal. 6 decimal e to the negative 11. And what that's telling you is that the big E stands for exponent. So what it really means is 6 times 10 to the negative 11. You have to learn that. It will show up on your AP biology exam. You'll be doing some math equation and then you'll get this E and kids freeze all the time. So you have to remember E stands for exponent, and you just take it 10 and you raise it to that exponent, and that's what that number means. So the answer, and if we wanted to write that answer out in what we call decimal notation, normal notation, it would be the 6 with all these zeros in front. I've moved the decimal over 11 spaces in order to get that equation, or in order to get that decimal number. All right, let's try one more. Let's use a calculator if you can. I've got this really big number. We're going to multiply it out. So on the calculator, the answer comes out to 8.28 E plus 10. E means exponent, so that means times 10 to the 10th power. So 8.28 times 10 to the 10. That's what it means on your calculator. And now if you were actually to write it out, it's a honking big number. Okay, I think we're pretty close to done. So now it says, write in proper scientific notation. Notice the number is not between 1 and 10. So for this first problem, it's 234.6 times 10 to the 9th. You need to move that decimal over 2 more spaces. How does that affect, how does that affect your exponent? So it adds 2 more spaces or 2 more zeros to your exponent. So your exponent goes up by 2. So it's now 2.346 times 10 to the 11th. If we go the opposite direction, notice that right now the decimal's in the wrong place. It needs to be between the 6 and the 4. So you have to scoot it over 2 places. What's that going to do to your exponent? It's on a calculator, sorry, if you entered this in on a calculator, it would be 642, but that's still not in scientific notation. So you would need to write it 6.42 times 10 to the 2. Notice it reduced your exponent by 2 when you scooted the decimal over in the right direction, to the right. There we go. All right, ladies and gentlemen, that is it. I'm sorry I talked fast, but I didn't want this to take too long. And everything that you need to know about this is already in your textbook. So if you still have questions on that, you can read your textbook and then contact me if you're having troubles after that. See ya. I don't even know how to shut this off, actually. That's fine. Pause.